Hi all, this video is on inverse functions. So the inverse of a function is denoted by f negative, a little negative one at the top and then an x. The inverse of a function reverses the effect of the original. So if we know that the function at 2 equals 4, then the inverse at 4 equals 2. So you just switch your numbers around. Only one-to-one functions have an inverse. So only if there's one x, there's one y, and there's only one y solution, only those functions have an inverse. If you have a function where it's 1 to 2 or to many, then there is no inverse. And an example of that will be a parabola, a quadratic function. There is no inverse there because there are multiple x's that have the same y solution. To find the inverse of a function, complete the following. So first of all, we write the function as y equals. We then swap the x and y. We rearrange it to make y the subject, and then we replace the y with our inverse notation. Quick example here, find the inverse of the function 3x minus 5 all divided by 2. So first thing we're going to do, step 1, write it as y equals. So y equals 3x minus 5 divided by 2. Step 2, swap the x and the y. So it'll be x equals 3y minus 5 divided by 2. Now rearrange it so it's y equals. So multiply the 2 to the other side. Add the 5. And then divide by 3. Then the last step is replace the y with our notation. So it will be the inverse of x equals 2x plus 5 divided by 3. And that's how you work out the inverse algebraically. Really simple. Example 2, if f of x equals 3x plus 5, find the inverse at 11. Now, two ways you can solve this. An easy way and a harder way. I'm going to do the hard way first because that's the way most of you will approach it. And that is you'll find the inverse and then input 11. So if we did that, we'd have y equals 3x plus 5, swap your x and y, and then rearrange. And then we'd end up with our inverse being x minus 5 on 3. And now we want that at 11. So we replace the x with 11, so it'll be 11 minus 5 divided by 3, which equals 2. So 6 divided by 3. Now the easy way you could have done this would be to remember how the numbers work. So if we want the inverse at 11, so if we're trying to find what this equals, this is the same as the function when the function equals that number. So we actually just had to do our original function equal 11. So 11 equals 3x plus 5 and rearrange that. So x equals 2. Much quicker, but under the exam stress and situation, what most of you will find you'll do is you'll revert to that first method, which is totally fine, it just takes a bit longer. So example 3, sketch the inverse of the following graph. So when you're sketching an inverse, the first thing you're going to do is work out where the line y equals x is. So in this one, it is nice and easy. It's right down the middle there. And when you're sketching an inverse, you just reflect the graph across this line. So you look for some points. So you see here, the y-intercept is 0, 4. So on the inverse, that will become the x-intercept. So just put a dot at 0, 4. It's going to cross that line at the same point, so that stays the same. And you just look for some other points. So you see here our x-intercept is at 0, 2, so that will become the y-intercept. And down here, this last point down the bottom, I'll just quickly circle in blue, is at 3, negative 5, so that will be at negative 5, 3 on the final graph. We also can see that this point here is at 1, 3, which means on our graph it will be at 3, 1. So you just look for points you can definitely see what they are, and then you just join the dots. And that's how you draw an inverse. And once again, that does sometimes come up in exams, and it's a really quick and easy way to draw one. And that is inverses.